This time we want to form an image on a screen 10 meters from a mirror. Our image is going to be 7 times bigger than the object. So what type of mirror do we need? And what is the radius of curvature of the mirror? Okay, a couple of key pieces of information. On a screen, anytime you're going to project an image onto some sort of screen, the screen could be a wall, it could be a piece of paper, it could be a movie screen of some sort. Anytime you want to project an image on a screen, it must be real. You cannot project virtual images onto any sort of screen. So our image in this case must be real. So that means our object, well, number one, there's only one type of mirror that will give us real images. And that's our concave ones. Convex mirrors, at least by themselves, can only give us virtual images. So concave mirror is what we need. Real images. We get a real image as long as our object distance is bigger than the focal length. What's the orientation of our real images? Upright or inverted? Okay. Exactly. So that means we have a negative magnification. We know our image is going to be 7 times bigger than the object, so our magnification, specifically in this problem, is -7. So knowing it's real, you know it's going to be inverted, so you need a negative value on your magnification. Now this 10 meters, what's our 10 meters represent? S prime, exactly right, because we want the image on the screen is 10 meters from the mirror, so the image is 10 meters from the mirror. So we know S prime is 10. Now positive 10 is appropriate. Real images are on the same side, they're on the front side of the mirror with the object. Real images have S prime values that are positive. So knowing magnification is negative S prime over S. The negatives will cancel, so we get 7 is equal to S prime, which is 10 meters over S. So S is 10 meters over 7. So 1 over S plus 1 over S prime is equal to 1 over F. Having 10 sevenths in the denominator is the same thing as 7 over 10. So 7 plus 1 is 8 over 10, which is 4 over 5. Flipping it over, our focal length is 5/4 of a meter, or what, 1.25 meters. We get a positive answer. You always want to make sure the answer you get makes sense, especially in terms of the sign. Positive focal length. Do concave mirrors generally have positive focal lengths?
Yes.
Yes, so that's good. Positive answer is fabulous. Our object distance, 10 sevenths, is bigger than, or bigger? What's 10 sevenths?
1.4.
Awesome, thank you. So it's bigger than our focal point, which is why we're getting a real image. To answer the actual question, the question wants the radius of curvature. We know R is just twice the focal length, so 2.5 meters would be our radius of curvature. So there's little pieces of information that you may have to pull out of the problem. For example, if you know you have a concave mirror, you need to put in a negative value for your focal length. Sorry. If you have a convex mirror, you need to put a negative value in for your focal length. If you know you're getting an image on a screen, then you know it's real, so you know it's going to be inverted. So it has to be a negative magnification. So sometimes there's little pieces you need to pull out from the way the problem's worded. Other questions on this particular problem? Yes?
Well, I'm trying to think of the only thing that I know of that projects real images, and that's an overhead projector.
These, we don't have anything in here that's, well, we might be able to do it this way. Hold that up. Come here.
There you go.
So my object is the bank of lights. My image on my screen, pretty cheap little screen, is the bank of lights. That's a real image. I'm projecting my image onto a screen, so it's real. Now we don't practically we don't really use mirrors in general to create real images, but we certainly can.
Now, how can a flat mirror do that?
Because it only creates virtual images.
So something that we can visually see, but it's not going to project it.
Yeah, in order to be able to actually physically project it onto a screen so that you can see it, it has to be able to converge the light rays, bring them together and form a real image specifically. You can certainly, I mean, I can look in here and see the image of the lights as well, that's fine. But
it's our perception.
Exactly.
Like if a tree falls in the forest, we don't want to.
Yeah, exactly.
Okay.
On your way out, I want you to look at this one. This one's kind of cool too. There's a little piggy that you can try to pick up.
Whoa!
But he's not really there. And it has to do, we have 2 concave mirrors, very finely polished.
Got him. That's sweet.
The light bounces around inside the mirrors, forming a final image there at the top. So it looks like he's just standing on a mirror. Yet if you try to pick him up, he's not there. So.
Awesome.